So hello everyone, today we are going to demonstrate the experiment Hall effect. Okay, so in this experiment we are given a sample of germanium. Okay, so we have to determine the Hall coefficient and mobility of charge carriers in a given sample of semiconductor, and that semiconductor is germanium. Okay, so in this apparatus here we have used this is germanium 5202 crystal, as you can see. So so as you can see, this small black sheet is actually pure germanium. Okay, so and from this we are getting four wires are coming out from this. Perpendicularly we have to apply voltage and current. Okay, so we'll insert it here perfectly. So first of all, what we have to do, we have to determine the Hall coefficient using this formula: IH equals Vz by Ix times Y by Vy. Okay, so first of all, we are given the dimensions of the sample. It is 7 millimeters in length, and wide for 5 mm, and its height is 0.5 mm. It means its thickness is 0.5 mm. Okay, so first of all we have to determine the Vz naught, that is the reference Hall voltage that we will use to calculate the final Hall voltage. Okay, so for this, in the first table, what we'll do is that first of all we will put no magnetic field, that is from here we are providing the magnetic field. Here it is also written IH. Okay, so from this current control we are actually giving the magnetic field to these coils. You see, these two wires are coming from these coils, and these two wires will be connected like this. Okay, so first of all, in first table we just have to keep it off. Constant current power supply, we have to keep it off, and then we'll turn on the Hall effect setup. Okay, so first of all we have to make sure that the connections are in positive polarity, I plus. What it means? It means that this wire this wire that is coming from the germanium crystal, so it has four ends. Okay, so two are going to current and two are going to voltage. Okay, so you can see it clearly like this. Yes. Okay, so from this, as you can see, red one is going to black, and red is going to red, black is going to black. Okay, so first of all we'll give the Ix, that is input current to 0.5 milliamperes. So we'll this is a switcher knob. So on right side it shows voltage in millivolts, and on left side it shows current in milliamperes. Okay, so first of all we have to put it on 0.5 milliamperes. So yeah, it's almost 0.5 to milliamperes. We don't have to touch this knob, it's just for offset adjustment. And from this we have to measure the output voltage, Hall voltage. Okay, so here we are getting the output voltage. This is Vz. Okay. Okay, so that was our first reading. Now for the negative polarity part, what we have to, we just have to switch these terminals, negative to positive and positive to negative. So and make sure that in I plus polarity we will get a slightly greater voltage. Like previously we were getting uh, 40.2, and now after changing the polarity we'll get 40.7 millivolts. Okay, so here also you can see in positive polarity we are getting 41.1, and negative polarity 42.6. Okay, so similarly for the second reading, we just have to put it on current position and increase the current to 1 milliamperes. Okay, so it's almost 1 milliamperes. Yes. Okay, now we'll measure the voltage. Okay, so it's coming out 41. Okay, and make sure here it is negative polarity. Okay, so first we'll write negative polarity with 1 milliampere. We are getting 41. Okay, now for positive polarity what we are getting, 39.67. Okay, so as you can see here also we are getting less. As we increase the current, our whole voltage also decreased. Okay, and in further as we increase our current, our whole voltage will be decreased. So let's say for 1.5, for 1 point, yeah, 1.5 we'll get lesser whole voltage. Okay, 39.3. Okay, so similarly we have to take other readings for different values of current, and we have to note down whole voltage. Okay, so first part is simple. Okay, now for second part. So for the second part, what we'll do, we'll turn on the constant current power supply. Okay, so as you can see here it is 0, IH is 0. Okay, so we have to increase it up to zero point 0.5 amperes. Okay, so we'll increase it 0.5. Yes, it's almost zero point 0.5. Okay, now what we have to do, these two wires are coming from the current part, and we'll connect it here, and we'll turn on the multimeter. Okay, and we'll note down the Vx. This Vx is the voltage noted down from multimeter, and correspondingly we will measure the Vz. Okay, so here we have Vz.
So, a very good afternoon to all of you. This today we will do first experiment, Hall coefficient. So, to determine the Hall coefficient and mobility of the charge carriers in a given sample, basically Hall coefficient. So, in Hall coefficient we have three tables: first table, then second table, and then third table. First of all, we will do for the determination of Vz0, Vz0. For this, we will do first table, polarity, current, Hall voltage. For first of all, we will turn on our setup, and we have to put IH is equal to 0.0. So right now it's I have given IH is equal to 1.0, and before that it's check also that in setup your semiconductor is placed symmetrically in between or not. So as you can see here, it's almost symmetrically placed in between. On the top you can see in between symmetrically you have to place your semiconductor so that reading will be correct. Please ensure before starting the experiment, and make sure put IH is equal to 0.0 in first table. Now here above, see offset adjustment, this you have to like is minimum, but you have to put it maximum here. So maximum of output, offset adjustment. After that we have two options: current and it's for the current variation. You will vary current through this knob, and also here you have the changing knob which will change current and voltage. So first of all we have to set, see in the table, see we have to give current 0.5 ampere, and corresponding that current we have to measure our all voltage. So first of all I have to set current. To set current by putting I have changed my knob. See here I have changed my knob to current, and then uh, right now my current is 0.02. So slowly I will increase my current to point, for example I it's almost point 0.5. It's almost point 0.5. So right now my current is 0.48. It's almost point 0.5. So corresponding that current I will note down my wall voltage Vz0. Vz0 is 40.2. So see here corresponding my current I plus. First of all I have given polarity I plus, For I plus 0.5, 40.1. Here my first reading is V z naught 40.1. Now I have to measure I minus also. So what is I minus? It simply means to have to change the polarity of current. So for changing polarity, again I have to move my knob to current knob. Then for I minus, again I'm repeating, changing polarity, you have to move from here to here. Then again change the polarity. See here, current, I am changing polarity, wires. Change the polarity. Again it's 0.5. Now again I will measure my voltage. It's almost 40.8. See here also in table it will show almost 40.8. Here it's 40.26, but don't worry about it. Whatever comes right here for I plus and for I minus. Simply then again uh, change the polarity again to I plus, and again I have to measure. See in the table I plus for 1.0 here. So again sorry for inconvenience. So again I was telling B positive here, positive polarity of B plus here, as I have taken. See make from far angle so that it can be positive polarity here is, and it's B plus here. So for positive polarity B plus, and also for I plus positive is connected to positive. I have set current here. See in current now it is showing 0.42, so slightly increase it to 0.5. It's 0.5 almost. So with at 0.5 it's almost 38.8. 38.8. It's 39.9. It is showing V prime Z, our voltage now is almost. See current 0.5, 0.5 almost, and
फर्स्ट हैंड
voltage
वोल्टेज सेकंड हैंड वोल्टेज क्या है?
38.8.
ये फर्स्ट एंड ये
Now
V1 V2
अच्छा
for I negative, I have
V1
to
और
change
V2
for I negative I have to change my current polarity. So simply I have told you for current polarity, see here current, change simply positive to negative and negative to positive, positive to negative, negative to positive. Current polarity is changed. Now observe here current is almost 0.5 or not. It's not 0.5, let's slightly increase it to 0.5. You will increase it from your side at the time of experiment. So I have considered 0.5 almost. So in this case it's 42.4. So you will write here almost 42.4 in case of positive polarity of B and negative polarity of current. It's almost 44.42, yeah, whatever it is. Okay. Now second thing, B negative. Simply again watch out clearly what the polarity of the current knob and magnetic field knob. Right now I've set it again positive, positive. Now I have to take B negative. So for B negative, negative positive wire to negative wire. B negative is connected now. B is negative, and for B negative I have to take positive. So means positive should be connected to positive. So current now is connected to positive. It's good. Current is here 0.5 ampere. So again I will check my current is 0.5 more now. It's almost 0.5, so that's fine. I don't need to change. Then again at zero point 0.5 current I will check my voltage. It's almost 41.8. So at 0.5, see here B negative, I positive, its V prime z is equal to 40.42.8, which that also makes sure that in these readings you have to measure Vx also. Like I didn't tell you earlier for other readings, but make sure you have to measure Vx also for each reading. Like here at positive positive what was Vx, at positive negative what was Vx. So we have to measure, like for this condition our Vx is almost 2.22. So it's, see here 2.47 is almost, it will vary
and
slightly.
don't confuse in Vx and Vz prime. Vx is the multimeter voltage and Vz prime is the hall
All
voltage.
voltage. Vz you will when measure from this apparatus Vz time here, and Vx you will measure from multimeter. Okay, so it's like this. You have to take all the readings by changing polarity. And then, last, let me tell you one more thing, like how to negative. So B is negative here. This condition B negative, I negative. B is negative here as I have changed because positive is connected to negative. Here our positive is connected to positive, so I have to make this current also negative. So positive is going to negative simply. So both current knob and magnetic field knob are also negative, both condition. And in this condition current is zero point 0.5. So zero point 0.5 current, let me check. 0.5 current, fine. Our voltage now, I have changed voltage now. It's almost 39.2. So 39.2 is V prime Z, almost 39.2, and correspondingly I can measure Vx also. It's 39.2, it's 40.9 here, but almost it's fine. 39.2 will be here, and Vx correspondingly, Vx, it will be mean Vx correspondingly here, it should be 2.75 here, 2.75, B negative, I negative, 2.75, like this here, sorry, 2.75, like this here it should be. So you have to take further average, you can do calculation from your side. So that's how you have to take reading from for 1.0 ampere, 1.5 ampere, 2.0 ampere, similarly.
And explain the calculations also. So for similarly we have to do the third table with 1 ampere IH.
Let me tell,
Okay.
like right now IH is this. Again I will change my polarity to positive for the sake of simplicity, because we will always start from positive. So I will again make it to 1 for third table. IH is 1 right now. See, IH here is 1 right now. Don't confuse in IH and IX. IX is this current above white power supply, which is the current adjacent here. You will set it here. And IX is equal to 0.5. Um, B IH is equal to 1.5. Now, for 1.0 ampere, again you have to do the same process as I have told earlier in second table. So it's almost same. You will do for 1.5, you will do the same thing like earlier you did for zero point 0.5 in the third table. So that's all from
Now
my
for
end.
the calculations part, we have to make actually for these last two tables we have to make two graphs. Okay, so the first graph will be is between ix versus vx. Okay, so this ix versus vx, and one graph for ix versus
Visa.
vz. Okay, so here is our formula. This is our formula. Okay, so vz over ix, this graph we have to calculate the slope, and here it will be slope, and this is the dimension of y is the dimension of semiconductor, dy is the given magnetic field. Okay, so this is how we have to calculate the Hall coefficient.
Yes.
Okay,
Magnetic field
and
you will see from
dy,
here, like
magnetic field in Gauss value, it is this.
in point 5 keys you will have 796, and one keys we have
Don't confuse with
14.87
these current. These current are actually IH,
IH.
magnetic field current.
Like let me tell you, like for, you have done two tables, right? Table 2 and table 3. So see here, table 2 IH is equal to 0.5. 0.5, in this case you will take magnetic field 796. Then again third table 1.0, for this table you will take magnetic field 1486
1486.
simply, and you will do calculation according to
And
formula.
these given magnetic field value are in Gauss.
Gauss.
So we have to convert it to Tesla
Tesla.
by multiplying by 10 power minus 4. And these are the calculations that we have done. So
You may observe it, and
yes,
you
these are
will
the
have in your
calculations.
notebook, so they are
Okay,
like
so
strong.
that's all about this experiment. Thank you.